So let me start my talk, Anatomy of a Claw. Now, I think it should be quite familiar to most people. OpenClaw is, a big thing that happened in February. It wasn't originally called OpenClaw; it was called CloudBot back in the day. They had to do some renamings, and now OpenClaw is a phenomenon of sorts. And the interesting thing for me is that this is not necessarily the first agent that can do the things that OpenClaw can do. But it did do some things in an interesting way that have been copied from others. So just for more background, I'm not just going to be talking about OpenClaw here. I'm going to talk about some other things like the Hermes agent. There's like coding agents like Pi agent, which has a very interesting domain name. And NanoClaw, for example, NVIDIA made their own NemoClaw. Just kind of like, oh, this is the secure one, but it also has some security things. And I will, briefly talk about Express AI and our platform because this was pre-Claw days. So I have, that kind of perspective of things. But I would say the interesting thing about what changed with OpenClaw and a lot of these things is that this idea of an agentic harness, which is a word that started happening, although it makes sense, I was calling it a harness as well, really became this front and center thing in a lot of people's minds. So I would say like, back in the ChatGPT days and when people like Anthropic released a new model or Mistral released a new model, a lot of the um, how would I say I'm trying to think of another word other than hoo-ha, but like the things that people are talking about were really all about the LLM, how it could answer questions or solve mathematical problems. Now, these are interesting and important kind of details to an agent, but for me, I've always been uh, not very interested in how well an LLM can pass a test, for example, because they have memorized a bunch of things. And it's kind of, to me, not very interesting to see what they can memorize. Instead, it's more interesting for me, since the beginning, to see what they could do. And in the beginning, they couldn't do too much. Going back to uh, like one of my old slides very quickly, because I did have something in there I think made sense and find the Canva in here. So you can see in this image, there's the agent and it has actions and it could perceive things, right? So this setup, which I call an agent here, I think has been replaced in the world as a harness for an LLM. And so this kind of combination of something that drives an LLM and gives that LLM access to tools, is the thing that becomes the harness. And OpenClaw calls it like gateways. And one thing that I think OpenClaw stumbled on, which is something that builds on top of Claude Code, is this idea of using regular files like Markdown files to do stuff and to schedule and become the memory of the system. So if you're going to make an agent harness or your own agent harness, I think the main things you need to think of are how does, this idea of this gateway, right? So you have essentially a process that is your harness that is connected to an LLM. And then how does the users interact with the system? So a simple one is that they interact with it through the command line, right? Like standard in. You could also create a chat application or hook it up to something like Telegram or something like that. And this becomes the main way you interact with your agent. It's kind of running in the background. So being able to send it messages is this idea of this gateway stuff. Then one of the most important things, I think, for an agent is the memory. So you got to remember an LLM has a static set of weights that never change. And what can change, the whole idea of LLMs are few shot learners, is that you can put a few examples into the context of the LLM and then ask it a question, and it somehow is able to use that context to understand what it needs to do, and then answer you appropriately. So the memory system for an LLM that has static weights has to come from somewhere. And so in things like OpenClaw and others, the idea is the agent saves a bunch of files on the file system, and then reads those, loads it into its context, and then works from there. And anything that it has learned needs to become a file and then saved so that it can, remember that later. So that's an important thing. The other thing that I think is important for an OpenClaw harness is this idea of this proactivity that it has, right? So in OpenClaw, these are called heartbeats and crons. So the heartbeat is an interesting feature of OpenClaw, where the agent every 30 minutes, and I think you can configure this, essentially reads a file that's stored in the OpenClaw folder, and the LLM or agent then uses that file to do something. So if you told it, for example, I want you to remind me every 2 hours to get a drink of water, and let me know what I should be doing next, or something like that. It has other options of doing this, but it could write this information into the heartbeat.md file, and then it will read that and then do something about it, essentially. The other thing is the cron jobs. Now, this is actually a feature that I think was added to ChatGPT and Claude as well, where you could say something like, remind me every day at 9 a.m. to do something. So these kind of cron jobs are also a feature, but yeah, they're kind of different from the heartbeat, because the heartbeat always executes, and the idea is that it doesn't have a one task to execute at a specific time. It's more like there's a heartbeat MD file that it will read, and then using that context, it goes and figures things out. And if the sorry about my son there, and if the heartbeat MD was if it needed to add more information to Heartbeat MD, it would just write that in there and update it little by little, if that makes sense. Then the other thing is the loop, right? So you might be familiar with this idea of React, where you would tell the agent to think step by step, and then it would kind of give you its reasoning and then continue. These things are kind of implemented in Claude Code as well. And the Claude SDK, which is what OpenCode is kind of built on top of, where the idea is the agent has tools available to it, and then it needs to make a plan, use the tools, see the result of the tool, and then continue with the next step of the plan. So you don't have to use Claude SDK to do this. You can actually set it up in a bunch of ways, which I have as well. You can actually use React for this as well, and that works. Now, the important part, which I think makes it, an agent, an actual agent, is the tools, right? So one thing that I think made OpenClaw in particular be a lot more successful than others, and I think it's mainly by accident because it's built on top of the Claude SDK, is that it has the ability to run Bash scripts. It can execute commands in Bash on that computer, and update files. Now, this tool is kind of like a universal tool. If you can run Bash scripts, you can use that to find the current time. You can use that to call curl or wget to download a file from the internet. You can, tell the computer to reboot itself, for example. This tooling part is what really makes the agent able to do things. So it's important to think of what tools you provide to the agent, because that directly correlates to what the capabilities of that agent will be. And one thing that I think is underrated is the observability part, right? So a lot of people get surprised when they're using OpenClaw with APIs because of how much it costs to do simple things. And that really shouldn't be a surprise to a lot of people. You should, think of when you're making a harness, like how do you budget things? You can just YOLO it, and it'll be a nasty surprise. But then also the safety aspects, right? Should you allow it to RF everything? If it got into some weird state, you have to worry about like prompt injection. How do you mitigate those kind of things? So if you've used Claude Code, you've experienced this quite a lot where you have to approve every single kind of iffy command. And that doesn't necessarily go away if you're using OpenClaw. And it becomes very important. The more capabilities you give to the agent, the more what's it called? Like security problems you make for yourself, right? It has the ability to make bigger mistakes. So you definitely want to be careful about what you do there. So I would say one thing about OpenClaw, which I don't think really OpenClaw did, it was more like a kind of feature, I guess, of the Claude SDK, is that OpenClaw kind of relies on a single chat context for the agent. And that chat context becomes, of course, it's memory because that's understanding this conversation, but it's able to kind of talk to various channels and understand everything. So, for example, if you talk to OpenClaw in a Telegram message, and then later, let's say you have it connected to email and you send it an email, you're talking to the same agent because it's just a single conversation. Now, this is something that, back in the day, we could not do, right? When ChatGPT, when GPT 3.5 Turbo came out, it had like a 4,000 token context window. So managing the context was incredibly important. And once you ran out of context, that was kind of it. There's not very many tokens to deal with. So with OpenClaw and the Claude SDK, they have this idea of compaction that takes the entire conversation and compacts it into a smaller footprint periodically. And I think that context management is an important part of what makes OpenClaw versus what we had before. Now, one of the other things when it came to tooling here, like you have like Python scripts, MCP servers, and shell commands. Back in the day, earlier, you couldn't really rely on the agents to make, Python scripts very well. The earlier models could make you a simple kind of like merge sort or quick sort algorithm, for example, but they weren't able to one-shot a script that would execute successfully. And when it started making mistakes, that would kind of spiral out of control. And because of that, there's a lot of like MCP servers and fixed tools, fixed functions that were created for the agents. And yeah, now because we have, really better and better LLMs, you don't need to worry about that so much. They can actually make their own tools. And that is kind of evidenced by the fact that there's like the create MCP skill in Anthropic's tooling right now. Yeah, and then, back in the day, there was things like this last part about, scheduling and human in the loop to trigger actions. One of the earliest versions of Xpress AI itself was something like an N8N, right? And N8N is probably a lot of what most people are using before they use OpenClaw to do things. You kind of have to lay things out step by step for an LLM to do it properly. And that's what we did before. But nowadays, you don't need to worry about that because the agents are able to one-shot these things more and more. So you can just tell them what it is you want it to do, and then they can figure out the rest on their own, as long as they have the tools to do it. So that's the interesting thing about that. So yeah, I would say let's think about what made OpenClaw successful, right? That for me, that's one of the most interesting questions because I've been working on agents for a long time, and OpenClaw exploded more than the others. Now, I think the omni-channel gateway that they have, where there's just a bunch of connectors that go into the same agent, was definitely one of their most important features. Um, and you should probably copy that if you're going to try to compete with OpenClaw, I think. The idea that you meet people where they're at is a good one. In my own product back in the day, I also thought the same thing, which is why we added email support very early because I email people, so I just want to email my agents. And that, setup is definitely true. The other thing I think that is underrated is that markdown memory, right? So the OpenClaw system has sol.md, memory.md, skills.md, just a few files. And that really shapes how that agent actually behaves. And it's easy for you to just tell it to update its sol.md with some new thing, right? So if you want it to act like a total Chad, no matter what's going on, you can just tell it to update its MD and it's like give me some of that Chad energy every day, just make it work that way. And then the other thing that I think made OpenClaw very successful was the fact that it's very extensible. Um, the ability to just have that claw hub that they have and then import these things into OpenClaw made it so that a lot of people could get started with their specific use cases very quickly. And I think the other side to that is that it's also possible for OpenClaw to install its own um, extensions, right? Like that's one of the most powerful runtime loops here. Um, and then there's the heartbeat. The heartbeat, I think, is what really gives OpenClaw that like really, what would I say, like proactive sense that you miss from ChatGPT. ChatGPT in general doesn't tell you, doesn't like contact you out of the blue for something, but OpenClaw or in Express AI, the agents will chime in the mornings like, hey, it's 9 a.m. Did you remember to do this thing that you said you would do? And stuff like that. And that becomes very, very helpful. Now, XpressClaw is the thing I'm currently working on, and that's why I've kind of learned about OpenClaw very deeply, because I wanted to understand what is different between that and what I've been doing. Now, my pitch for XpressClaw rather is that we have a very small single binary that is local first using local models with support for OLAMA and things like that with budget controls. So even if you don't use a local model, you can put a budget onto your agents so that you make sure that they stay within their budget and then they get stopped or downgrade into a local model if they go over the budget. And I think that one thing that I found with OpenClaw that made it difficult for people to get started was that it needs to be connected to something first. And I don't see why you couldn't just create a simple chat UI built into the system and then connect it later. So I did that. And, I would like to address the security issues that happen in OpenClaw. Like I felt very apprehensive of installing OpenClaw on my own computers because of the complete lack of security. So when I made my own XpressClaw, because I felt like I could do much better than this, we used Docker containers to isolate the agents in that container, and the only files it can access are the ones that I give it, and so on and so forth. And of course, you want to have logs and status monitoring. So we created something like that. I can show you a little bit what it looks like right now. This is an open source project that I'm doing. You can kind of add an agent, and we have like some templates, like this assistant agent, for example, that can run with OpenAI, OpenRouter, or some models that we have built in that I've handpicked. We select the one that works on your computer, given the memory size that you have, and if you try to select the other ones, it'll warn you that your computer might not have the memory for that, for example. You can talk to them and see the thinking. They can use tools. Let me see if I have something where tools is kind of in development right now, so there's lots of errors here and there. And yeah, so that's what the chat system looks like. There's also the task Kanban board along with schedules. So you can create a schedule to have something be done at 9 a.m. like you would expect. We have workflows. So we have like this procedure system that allows you to kind of create some kind of procedure, like a SOP, for example, for your agent to do things step by step. And because you can create more than one agent in XpressClaw, you can create multi-agent workflows that have like one step set for a specific agent, and then you can loop over some entities or create like conditions, and like say when it's rejected, you go back to this step and try it again, for example. So you can kind of create these multi-agent workflows that I think are really good for doing stuff. But yeah, so that's all I'm really going to talk about XpressClaw. But it's an open source project that I'm working on. If it looks interesting, please feel free to help out, I guess. The architecture that I created here is one that I think is also shared by a lot of the like security focused LLMs like NanoClaw. But with NanoClaw, it doesn't use Docker, it uses their own kind of thing. But there are many others that have this kind of, you have Docker and then the agent runs inside of Docker and calls out to the outside world. The way that we've implemented security here is the XpressClaw server is set as the LLM of the agent that's running in the harness. So we can intercept all of those calls and run them through any rules that we have. So if it's using like an email tool or something like that, you can set it up so that it can't send an email or can't access some file on Google Drive, for example. Yeah, also set up memory and things like that inside of XpressClaw so that you can have like a single place where all the agent's memory is, and it's easy to back that up and move it to another machine, then restore that memory, because at the end of the day, the agents are the models which you can get anywhere, and then the memory is the main state of the agent. So like I said, with XpressClaw, there's the chat first UI, that memory, and the tasks. I think these are the main pillars of any OpenClaw kind of thing. So yeah, that's enough of that. Let's look at the other ones, right? So there is, I have 4 here because these are the ones that I look at the most. So of course there's OpenClaw that use that markdown state management. And one of the more interesting coding agents that I think a lot of people use, not just for coding, is the Pi coding agent. Now, the Pi coding agent is a very minimal kind of like not OpenClaw, but like it's a minimal layer on top of, I would say, Claude Code. I mean, it's not on top of Claude Code, it's a separate thing, but it's very similar. It was kind of made originally for code, but because it has all these hooks in it, people use it and then add these hooks, these extensions to make it into their own kind of claw-like system. So I've seen a lot of people that really do that. And the fact that it has like this session history that's like tree structured, so you can fork off from a specific session, which is a very useful feature in coding, also makes it very interesting to be used as an agent, because you can kind of give it a bunch of state and then have that be something that gets forked every time you want it to do the same thing. One interesting one to me is also NanoClaw because of how small it is, right? Like uses only the Claude SDK. It's quite small. It can run like on a Raspberry Pi, for example. And it, also implements this container isolation thing that I was talking about. So if you are also interested in the security aspects and how do you kind of, try not to open Pandora's box, NanoClaw is kind of how you should do that. And then Hermes is interesting mainly because you know, it's trying to do something that OpenClaw kind of does, which is like the agent itself self-improves. So one of the interesting features about OpenClaw is that the agent has access to the OpenClaw code as part of it. So you can actually tell it to add features to OpenClaw. You can then no longer update it very easily without asking the agent to update it itself. But like that idea of making something that can self-improve, which people used in OpenClaw just to give it more features, is used in Hermes to like make it better. So it kind of has a step for make yourself better given your experiences. And that's something I also want to do in XpressClaw at a later date as well. So you might be wondering, okay, so how are these different, right? And there's a lot of things to think about. But so I asked my agents to create a whole table of the differences between them, and this is the result, which I think is interesting in certain ways, right? So with OpenClaw, you can see like one of the security models is like none, right? Which is very funny. And then everybody else, sees that and like, okay, no, we want to do something about that. So PyAgent as a coding thing is like OpenClaw, where it's like it's expecting you to be a professional, you know what you're doing. So it doesn't really have much in terms of security, but like NanoClaw and Hermes have different ways of securing things. Um, you can see that with like PyAgents, it's using agents.md. NanoClaw is just using the Claude SDK. So it doesn't actually have any memory state. It's just reading the Claude MD file, which happens in the Claude SDK by default. And then OpenClaw tries to do some more things with like this memory and skills. And yeah, you can see the different channels that everybody has. A lot of people are doing like integration with Slack and Discord, which makes a lot of sense. That was one of our first integrations with other channels as well. And yeah, a lot of people have, they use Open Router and things like that to support a lot of models. And I think that's an interesting thing. A lot of people are very interested in trying out other models. And, in a sense, the agent is its memory, right? Like you can think of a person in a similar way. Like there's a person is a sum of their experiences, I think. Like, so, if somebody has amnesia, it's much harder to relate with them. Like it's a challenge. That's why it's a common thing in movies and things like that. Because if they've lost all of their memories, it can be like or talking to a different person. So with these systems, because the LLM is like this implementation detail in a sense, you can switch out the LLM and just keep the memory system the same and interact with your agents in different ways. And I thought that was also very interesting, um, like difference between what was before and what is now. Now, there's some interesting, like this is a graph that my agents created to kind of illustrate the point of the different differences between OpenClaw and Hermes agent. And I think the interesting thing here is that self-improving part. I'm not sure I would put OpenClaw down here in self-improving because that's one of the things that a lot of people using OpenClaw do, where they ask it, please, add this feature, and it will add the feature for itself. But it is correct in the point where the agent, like Hermes agent, has this ability to, it's like the agent itself is trying to get better, not that the system is trying to get better. So from that perspective, that makes a lot of sense. But let's talk about the main thing, which is, okay, so let's say you want to design your own claw. What are the main things that you need? And I think these 9 things are what I would say are the main features that you would need, right? So figure out the channels that you want to integrate with, because that's going to be the main interface to your agent. It can be a voice interface, for example. That's also very fun. Um, but you could also hook up to WhatsApp because it's just running on your phone and it's bi-directional, which is the most interesting part, I think. Then you figure out what agent loop you're going to run. So like you could use React with LangChain. That works perfectly fine. You can do like Google Gemini style, where it's always like plan first and then execute. Then you figure out what are you going to do with your memory. So remember, OpenClaw has a very minimal, I would say, implementation. I mean, it's not as minimal as NanoClaw. That one is, it's just one file. But like there's flat files, and then that's the agent memory. I think there's a lot more that can be done in here, where you can mix different RAG approaches or vector databases or even more interesting things to kind of make the memory of your agent be a lot more dynamic, which I think is very important because the, you know, like we as humans, we have this hippocampal system that is always fetching these things for us, like what's it called? Like episodic memory, and then kind of translating that for our own brain to understand better. Another thing you need to do is figure out your tool calling setup. MCP makes sense, but really you don't need MCP, right? Like you could totally do things with bash scripts these days, and a lot of people are implementing like CLIs specifically for OpenClaw. So yeah, there's still interesting things to be done there. In the isolation model, right? Like Docker is something that I did, but you could also think of like WASM containers to make a claw that runs inside of a web page. That would be pretty cool. You could do that. Uh, like model router is a thing. Like, is a single model what you need? You want to have like a model that fine tunes itself and then uses that LLM? That would also be quite cool, I think. And then the bottom part is how you would, distribute that to people, right? So anyway, I think those are the main pillars of what makes a claw. It's very interesting to look at. I also have like this, or yeah, this is what I meant. These are the pillars to do the thing, right? You have the gateway, the tools, and the memory retrieval. So yeah, I think that's it. We're at 20 minutes. I could continue talking more if you would like, but let me check to see if anybody has um, any uh, any questions.